So it's a really important step forward in marine science to be able to sample our seas and oceans autonomously. It gives us the potential to get considerably more data than we could from vessels that were manned. A lot of the cost is associated with the staff costs. So this will help us get more and more data. The fact that that data can be streamed ashore real time is also going to be a great advantage. So from a vessel with nobody on it, thousands of miles away, we can be getting data almost instantly on the chemistry of the oceans, which will tell us about ocean circulation. It'll tell us about some of the frontal systems where different water bodies meet. We know that those are the places where some species are attracted to feed because they'll concentrate the plankton. So in the same time from the autonomous vessel, we'll be getting data, we'll be getting audible data, we'll be getting sounds of marine mammals that might be feeding there. Of course, one of the concerns is, do those frontal systems also lead to accumulation of plastic? And is it inadvertently then that the same things that bring together the food, the plankton that the marine mammals are relying on, also inadvertently brings a concentration of plastic, which could potentially put them at risk? It's really important to know exactly where the hotspots are, where the concentrations of plastic are, but also critically where the plastic is coming from and going to, how it moves around in the oceans. That knowledge is all really important if we're to tackle this global environmental problem of the accumulation of plastics in the ocean. Of course, we're going to need solutions on land. It's not the sea that made this problem, but by understanding better the distribution across our oceans, will only help us understand more about the problem, the potential impacts, as well as the solutions. Well, it's been a really exciting journey so far. I mean, having the ability to sense and to sample the oceans thousands of miles away from a vessel that's got nobody on it and the data relayed back real time, that's a real challenge. Of course, we've had inshore vessels that work autonomously for a while. We've got one at the University of Plymouth. But something that's got that range and capacity is really pushing the boundaries. And it's been fantastic working with IBM on developing some of the sensors that will help us to get data on ocean chemistry and on marine mammal noise. And moving forward, we're hoping to develop even more sophisticated sensors, perhaps to look at marine litter, for example. So having that ability to work with such a large corporation involved in the sensing of the oceans, coupling that together with the autonomous vessels and the scientific community here at the University of Plymouth, it's been a fantastic opportunity to bring together the science and the technology right at the cutting edge of the field.
So traditional research has used manned vessels, such as the project that I'm involved in, which is Expedition Around the World. So this autonomous vessel differs slightly in the fact that obviously there's no people on board, which means that we can actually cram it full of even more science samples and have more bits of equipment. There are pros and cons to each, but they can complement each other really nicely. Obviously with a manned vessel, we're limited on how long we can spend offshore and some of the places that we can go to. While with this new technology, we can send it offshore and just keep it out there for as long as we want, visiting different areas and continually collecting samples.